if you then, yes, thank you very much. And then you stop it. Thank you.
Yes,
Bye.
ma'am.
And afternoon, everybody. After a struggle, finally looks like we can get started. How is everybody?
We're
You're
good,
good.
sir. And how are you?
All right, man. Let us get started, man. Any question from the previous session? If there is anything that is still unclear, this is the time and the moment. Don't forget it. This is more about you than anybody else. We did areas. If you still have a question on areas, this is the time we can just revise it. Volume, we can just take it. Anything. If nothing, then let us go straight to today's topic. Can we? No question? Okay, perfect. Then let us look at today's session. But now, what is very important again is what? You need to understand this properly. Let's say you are given F and they want you to find the area under that F. And let's say between that F and the x-axis, or generally between F and G. Maybe the x-axis is another function called G. We have said that will only make sense if what? If your functions are continuous. That is, I've said it is literally, you know, street language, we will say a function is continuous if when you are sketching its graph, you don't lift your pen anywhere. Let me just say this. If I don't lift my pen anywhere, you can see here. Let's say I'm sketching it from A, this is A, and this is B. You see, then this function is continuous. But if somewhere they say whole, then this is not continuous. Therefore, the definite integral, not to say you cannot find the definite integral here. You can still find the definite integral, but then the definite integral from A to B, but then that cannot be interpreted as the area under that curve. Hopefully that make sense. Now, today we are going to look at what? The approximation of the area that we have just spoken about. Why are we talking about the approximation? I think last week, or okay, no, a week before, I think I gave you a bit of introduction to this topic to say differentiation, remember, is a straightforward process. We can almost differentiate all the functions. But now, when it comes to integration, it's tricky. We have said in some instances, yes, it will be very simple to integrate something because it will be standard, like saying integrate x with respect to x. This integrand x is simple because here it's got what? A standard formula because we are going to use this formula. We are going to use this formula, which will be x exponent n over plus 1 over n plus 1 plus c, provided n is not -1. If n is -1, then it will be lean, is standard. You can integrate it. And we have said again that there are those other integrand. Now, this is an integrand. This is an integrand, which are not straightforward to integrate. And again, there will be those integrand which are just impossible to integrate. Just impossible. Let's say something like this. Let's say with our syllabus. I think I'm writing this because they are using it there as an example. So integrate this. You can see that we don't have a formula for this. And in fact, one can even say it's not integrable. But now, what about if I say from 0 to 2? Is this function continuous from x equal to 0 up to x equal to 2? This integrand, is it continuous? The answer is yes, it's continuous. But now, can we integrate it? In other words, can we find the area between this and the x-axis? Don't forget, it's not integrable. But can we still find the area between this and the x-axis from where x equal to 2? No, from where x equal to 0 up to where x is equal to 2. Even if it's not integrable. You see, that is today's topic. And the answer is simply what? We cannot find the exact area because it's not integrable. But we can approximate that area. That is where this topic comes in. Although we cannot find the exact area, but we can at least approximate it. That is to say, it will be more or less approximation with this symbol, more or less it is. Hopefully that makes sense. And with that, then we can look at some now. Say you have this. I don't want to use those examples in the book. Say, okay, remember how many methods we have under approximation? We have got 3. One is called trapezoidal because it's using trapesium to approximate the area. The other one is called Simpson. It was discovered or what? It's product of Simpson. Then the other one is the mid-ordinate rule. So they are more or less the same. So all what we want us to do, or I want us to do, is what? Just look at how to derive one formula. Because your syllabus is not about how do you derive the formula, it's how do you use it. But it's always better to do what? To at least to give you a background of how that formula was derived. Then from there you can use it to look at the others, not necessarily to say how are the others derived, but at least have a better understanding of those formulas. Let us start with the first one. Let us just see how to derive the first one and from there apply it. The first one, as we have said, is called the trapezoidal. So let's say you have got what? A Cartesian plane like this. That is the x here and the y here. The x-axis and the y-axis. And you have this curve. Let's say you have got this curve. Like this. And then from there, let us call it F. And then I say find the area between this curve and the x-axis. Say from here, let us say this is A up to here. Let us say it's B. So normally we will say A is equal to the integral of F from A to B. But now the question again is, what if this F is not integrable? What we do with the first one, with the first formula, that is the trapezoidal, and another one is Simpson, then another one is the mid-ordinate rule. And we are saying, let us show you how to derive the formula for the first one. Then the other one, you will just mimic it. Just know it and then be able to apply it. Okay, what we are going to do is, like with the limits, like with the area, we do the following. We are going to partition this section from A to B, into equal, stripes or strips. You partition it. They must be equal in length. You can say, let me divide this into 6. Say n is equal to 6, meaning you now divide this into 6 equal parts. Let's say 1, 2, 3, 4, 5. Yes, it will be 1, 2, 3, 4, 5, 6. And please, from here to here, it must be equal to in length. From here to here, 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 equal to in length. From here to here. If from here to here is 7, then from here to here must also be 7. From here to here must also be 7. So on and so forth. Now, what we are going to do with the approximation is trapezoidal. Then you draw a straight line joining this and the last point. But don't forget, if this is A, then what will be Y here? If this is A, then what is Y here? Surely you know the answer, eh? X here is A. Because if this is A, then it means this vertical line is given by X equal to A. So, but now, the question now is, what about Y on this graph here? Exactly Y here on this graph. We know it will be f of A. If this is A, then it will be f of A. But let us just write it general and say, let's say this is xi, and this is xi minus 1. Therefore, y here it will be f of xi minus 1. Hopefully you can see. And obviously y here then, y here. Because if this is xi, then the whole line, vertical line, is given by the equation x is equal to xi. Therefore, y here on this graph is f of xi. On this graph here is f of xi. Then from there, you then draw a straight line. Straight line, I'm just looking for another color here. Straight line, let me just use what? Say blue or whatever, say straight line here, straight line. Even if it is not that clear, it's a straight line, but this is a straight line. Please don't come and say it's not a straight line. Say straight line. Straight line, please. Say straight line. Hopefully this makes sense. Then from there, what we're going to do is, then we draw another straight line here. Hopefully that makes sense. Then from there, we can even join this now. Say, geez, we can join them. It doesn't matter. We can join this. It doesn't matter. And even this, it can be something like, you may find that your curve is something like this. Then from there, you have got what? Your stripes here. Therefore, your straight line, it will then be from here up to here. Something like this. Straight line, it will be from here up to here. Now, if you look at this then, if you look at this, say coming back here, this now, you can see that you have got this, and we are looking at this area, the area of this under the curve. And you have again now, we have drawn again now a trapesium. That is this. Is now a trapesium. This is now a trapesium. But we are not looking at the area. We're not calculating the area of the trapesium. We are only interested in the area under this curve. Only the area under this curve, under this one. And now what we are going to do is now, we're going to say, okay, if you find the area of this now, say this. And now you sum them. Or let us simply say this. The area now of the trapesium, it will be what? It will be the area of the rectangle. That is this part. Area of this part. I'm talking about the area of the trapesium. It will be the area of this rectangle plus the area of the triangle. That is the area of this triangle now. You see the area of this triangle. The area of this triangle. And if you look at this, it will not be more than the area under the curve, because it will include this part, which is inside this triangle, but not below your graph. Hopefully that makes sense. Then if you look at the area of the rectangle, we can calculate it. There is a formula for that because it's a rectangle. What will be the area of this rectangle? It will simply be what? It will simply be from here to here, multiplied by from here to here. That is a rectangle. And what is from here to here? It is xi minus xi minus 1. That is this. Multiplied by this. And what is this? It will be f of xi. That is from here to here. Is the same as from here to here. It's the same as from here to here. And if this is xi minus 1, then from here to here is y, which is f of xi, then it will be this. That is the area of the rectangle. Now plus the area of the triangle. Okay, let me just start it here and see whether we cannot squeeze everything here. It will be xi minus xi minus 1 multiplied by f of xi minus 1. That is this, the area of the rectangle. Now, what about the area of the triangle? The area of the triangle, because obviously this is perpendicular to this. This is a right angle. Therefore, there is a formula for this. It will simply be what? Half multiplied by what? The base. And what is the length of this base? It is still xi minus 1. Then it will be xi minus 1. Then multiply by the perpendicular height. And what is the perpendicular height of this rectangle? It will be from here up to here. That is from here up to here. And we know it's a vertical line, therefore it will be y here. And what is y here? It's f of xi. And what is y here? It's f of xi minus 1. Therefore, this it will be f of xi minus f of xi minus 1. Up to this. Does it make sense? Yes, it does. From here, then, you have got this 2, but now you can see that this one, this is a common factor. You can take it out. Then it becomes xi minus 1 in brackets what then? In brackets this one, f of xi minus 1 plus half of what? Remember, this is multiplied by everything. It will be multiplied by what? It will now be half of this, which is half of f of xi minus half of f of xi minus 1, then close brackets. Hopefully it makes sense. Then these two, if you look at it, these two, f of xi and this one, they are like terms. Therefore, 1 this and minus half this is going to give you what? It's going to give you half of this. Hopefully it makes sense. Then let us just take this out and change this one to plus half. It will be this. Please make that you are with us. Then you can just simply take the half out because half here is against a common factor. Then this, it will can just simply say half in brackets this now. Half in brackets this. Again, if you look at this, it will not be what? Let's say this is B. Matter. Then it will now be the length of this. It will now be this now. It will now be B minus A over N. It will depend on how many stripes do you have. How many stripes or how many equal parts do you have? It will depend on N. And you still have the half here. Therefore, it will now be half by this. Then in brackets, f of xi minus f of xi minus 1. It will be this. And this is our trapezoidal formula for the approximation of the area. Does it make sense? That is the formula. And you can mimic it and what? and derive that one of Simpson.
I cannot see the screen, the full screen. Whatever you written down there, we can't see it.
At the bottom.
Yes, yes. Thank you.
But did you hear how we arrived at it? Now that you can see it. But did you hear how we arrived?
Yeah, I think that last step, the one before this one at the bottom, you wrap those things you written too quick for me to see what you were doing. Once you took out the common factor, I was trying to follow, and then those things you wrap there, I was trying to see which did you pick when you were taking out the common factor.
Common factor, which common factor have?
This one, xi
And the
minus
last one.
minus 1. The first, the one before the last one.
The half is this one. This half is this half.
No, look at the first one. Like after you've written area of the rectangle plus triangle, the second step after that, you see.
Are we together here?
Yes, yes. From here and then this one, the second one.
Okay, let us take it one by one. Are we together here?
Yes.
Are we together here?
Yes.
Are we together here?
Out the common factor there. I didn't see the complete thing. Once
which common factor?
Yes.
Because what we have said here, we can just simply redo it.
Yeah.
Let us just redo it. We have said from here, this is a binomial. Is a rectangle, the formula for the rectangle, which is this, and a formula for the triangle, which is this one, is a binomial. And this has got two factors. Is xi minus xi minus 1, that is the first factor. The second factor is this one. Now this one is half multiplied by this, multiplied by this one, which is the difference now, this one. So what we have said from here is what? If you look at it, is this and this one and this one. It's a common factor between these two. Then you can take it out. Then it will be xi minus xi minus 1. Then in brackets now what? Whatever is left. So what is left here is what? Where is my blue marker? Looks like it has fallen. I can't see it. Okay, but let us just proceed. I can't see it. Then it will be, you are left with this one. That's right.
Okay.
And then here, you can just, because this one is out now, you can just take the half, multiply it by f of xi, take the very same half, multiply by f minus f of xi minus 1. Then it will be half f of xi minus half f of xi minus 1. It will be this. Hopefully we are together. Then again, we have said, if you look at it, these two, this one, f of xi minus 1. And
so the last letter
this one.
After half, minus half.
The minus 1, remember, is I minus 1. This is I minus 1.
Yeah, okay, and then this is still okay. Okay, it is only 2 terms on this other side. It's
3. So 1, 2, 3.
I'm not counting the first from the rectangle formula. I'm only focusing on this triangle. This is what was confusing me. I can see this one.
Oh, it's 3 factors.
Yes.
It's half the first factor.
Yes.
Second factor is this one. Take it as 1 unit. Take it as 1 unit. Because it's from here to here.
Yes.
And then this one is the difference, but then take it as 1 factor.
Yes.
Because it's from here to here.
Okay.
It's f of xi minus because is the height of the rectangle, is the height of the rectangle, which will be y here minus y here.
Okay.
Because y here is the same as y here.
Yes.
Because it's a horizontal line.
Yes.
Therefore, y here is the same as y here on the very same line. It's the same as y here again. And y here is f of xi minus 1. Therefore, y here will still be f of xi minus 1. Therefore, from here to here is f of xi minus f of xi minus 1, which is the height, and take it as one factor.
Okay.
There from there, then here we have said these two, they are like terms because they are all f of xi minus 1. This is 1 multiplied by, this is minus half multiplied by. So you can add this one and this one.
Okay.
So then they will give you half f of xi minus 1. That is why I said, okay, instead of, we can just simply take this out.
Okay.
And change the sign here. Because the total will give you half of.
Okay. Yeah. Okay.
That's right. And then from there, you have got this in brackets, this 2. Then still, if you, this is half, therefore you can take the half out. Then it will now be half in brackets this. In brackets, f of xi minus f of xi minus 1. It will be this.
Okay.
It will be this. But now, coming back again, what is the length of this? It will now depend on what? The number of stripes here. If you have got 7 stripes, then this, it will be this minus this divided by those number of stripes. It will depend on how many partitions here. How many do we have? How many do we have? If you have got 6, then this now from here to here, it will be the whole length, which is this, divided by 6. This, it will be from here to here. That is from here to here, meaning this minus this divided by 6. Because we have said from here to here is the same as from here to here in length. It's also the same as from here to here in length. It's also from here to here in length. It's also from here to here in length. So therefore, this now, this, the length of this, it will now be in terms of, if you say this is A here and this is B, then it will now be B minus A over the number of partitions. And this is what is called trapezoidal formula or rule for approximating the area under the curve. The assumption is this curve is continuous. If it is not continuous, this is not going to make sense. It's continuous, but it's not integrable. Or even if it is integrable, the question may still say what? Find the area under this curve using trapezoidal rule, or using Simpson rule, or using mid-ordinate rule. It will depend on the question. We just have to answer the question. If they say use Simpson, you have to use Simpson. If the question is open, there's just saying find the area under the curve, then you can just simply integrate, if it is integrable, integrate and get the answer. And then that answer, it will be exact. But this one, it will be the approximation. It will depend on how many partitions. And the more partitions you have, the better the approximation. Hopefully that makes sense. But before we go far, Simpson will only be valid if you have got what? Even number of partitions. That is, n here, it must be an even number with Simpson. So n must be an even number. Otherwise, that formula is not going to make sense. Okay, now, if you understand this, then we can now try and expand this further. Try and expand this further to say, don't forget, this now, this subscript is a counting number. I cannot be a fraction. I cannot be a negative number. So now, what then next now? Therefore, this now, if you expand it, you cannot say replace I by what? Replace I by 0. No. Because if you replace I by 0, yes, this is going to be x 0. But what about this one? Because I is 0. It's going to be x minus 1. And does it make sense? It doesn't make sense because we are saying the subscripts, they must be what? Pound numbers. Therefore, you can only start with by replacing I by what? By 1. Not by a negative number. Not by 0. No. So if I is 1, then this formula becomes half what? B minus A over N in brackets what? If I is 1. Then this is going to be f of x1. This is going to be f of x1. What about this one? It's going to be f of x. What did we have here? Is it minus? No.
I think you
this
changed.
Is not minus. That is what?
It was plus.
That is plus. That's right. So it will not be plus f of x what? 0. So let's say if I is 2, then what about this one? It's going to be f of x2. What about this one? It's going to be plus f of x1. The same story. If I is 3, then this becomes f of x3 plus f of x2. Then if you look at this formula, this, they are going to give you 2f of x1. These 2. So therefore, the formula now, you look at this, the formula now becomes what? This one. Because you don't have f of x, another f of x0. You can't have another f of x0. This, it will be the only f of x0. Therefore, it will be f of x0 plus. But what about f of x1? It will be this 2. Therefore, it will be 2 f of x1 plus these 2 again, these 2 is going to give you what? 2 f of x2. Is there a question? I saw a hand somewhere. No question. I saw a hand. Okay.
Yeah.
Was it a question?
We cannot see the screen, what you are writing up there. I think there's a discrepancy.
Oh, okay. Again.
The top, we can see. Yeah. There. Thank you.
Again. You see. Then this will continue. This 2 here, 2 here. It will continue. It will be in each and every term in the middle. Because if you say I is equal to 4, then it's going to give you f of x4 plus f of x3. You see. So meaning this now is going to give you plus 2 f of x3. Until the last one. The last one is not going to repeat itself. Therefore, the last one, it will be plus, now you say until f of xn. It will depend on what is n. And the one before this, it will be 2 f of xn minus 1. The one before this, it will be 2 f of xn minus 1. Before that, it will be 2 f of xn minus 2. So then this is what is called the trapezoidal rule. This is what is called the trapezoidal rule. Then if you understand it, then you can just use it, whatever. Even if something is integrable, you can just, even if the integrand is integrable, you can just use it. But don't forget, it will only make sense if your function is continuous from A up to B. It mustn't be continuous in any of these. Although, yes, then maybe the definite integral will still exist. But then you won't say is the area. You can't say is the area. Like say what? Like say what? The integral, I'm not sure which one, say 1 over what? Say 4 minus x squared, say from what? From 0 to 2. Can you integrate this? That is, can you find the answer here? Yes, we can find the answer. Why? Because this is standard. This is standard. This is standard. Which formula are we going to use here to integrate this? I think it will be inverse sine x. It will be inverse sine x because it's exactly this one. It's exactly this one. A squared minus f of x all squared. That is this one, which is inverse sine x. So then the answer here, because your f is not the whole, no. Because we are not using the general power rule. But if you have got x here, yes, then it will be the general power rule. It will be the general power rule. That is, you are now going to use it is now. You are now going to use it is, which is the general power rule. It will now be what here? From 0 to 2, x in brackets 4 minus x squared, exponent this, dx. It will be this. It will be this. Where your function now, where your function is everything inside. And the derivative of this is minus 2x. Then you just have to write minus 2 here and cancel it outside. There from there, use the right side of the general power rule. Hopefully that makes sense. But now, if this is now a constant, say 3 here, then you can no longer use the general power rule. You can only use it is where your function is now going to be x. Your function is now going to be x. Your function is now going to be x. Then you're now going to say, according to this, if my function is x, is my numerator is derivative. Then you can see, oh, the derivative of x is not 3. But is what? Is you can take the 3 out, then write 1 here. And you don't even have to cancel anything, counteract anything. It will just be straight this, which will now be 3. That is inverse sine of your x, your f. What is your f? My f is x over what? This is not a, is a squared. This is not a, but it's a squared. So if a squared is 4, then what is a? A then is 2. You see, then you integrate this from 0 to 2. Hopefully that makes sense. But how are you going to interpret this? Are you going to say, is the area under this curve? The answer is no. It cannot be the area under this curve. Why? Because this function is not continuous from 0 to 2. Because when x here is 2, when x here is 2, when x here is 2, it's not continuous on the upper limit. Because when x is 2, then this it will be 3 over the square root of 4 minus 4. 4 minus 4 is 0. The square root of 0, 0. Then this it will be undefined at 2. Therefore, yes, you can find the answer, but you cannot say is the area under this. And even when you use this approximation, because this cannot say the answer here, you can't say is the area. Therefore, even if you use the approximation, this is not going to make sense. You won't get an answer using this, because the aim of this is to approximate the area. Then if the area doesn't exist because this is not continuous, then how can you approximate something that doesn't exist? Therefore, this will tell you this, it can work with this one. This approximation, it can work with this one. Hopefully it makes sense. Whether you're using Simpson or whether you're using trapezium or whether you're using the midpoint, it won't make sense. Hopefully that makes sense. Now, if everything right, then we can just look at one problem, but then use all the 3 methods just for practice sake. Use all the 3 methods. Say find the area, approximate the area, say of this, from 0 to 2 of 1 over 4 plus x squared up to this. Will these 3, either trapezoidal or Simpson or the mid-ordinate work? Yes, it will work. Why? Because this is continuous. This function is continuous in this interval from 0 to 2. If you replace x here by any real number, starting with 0 up to 2, there will be an answer. Therefore, this is continuous from 0 to 2. It's continuous from 0 to 2. But because it's integrable, yes, you can find the area using just straight integration without approximating it. Why I'm saying this is because what? If you still have time, just check it, because it's integrable. Integrate, find the area, then from there compare that area with your answer using the approximation. So what is this one now? Can we integrate this? Before we even look at the approximation, can we integrate it? Yes, we can integrate it. Using which formula? Is it the general power rule? No, which one is it? Which rule are we going to use here? We are done with integration. Surely, even with our invitation, we always remind you to do what? Go back and check integration, because there is no way that you can apply integration without reverting back always to integration, reversing back to always integration. because here we're talking about the applications. So which formula we going to use here? You can say the general power rule. It can be this. It can be this. It cannot be this. That is, when you rewrite it is because the general power rule is in product form. A something multiplied by something. But the other factor is a power. It's not in fraction form, it's in product form. Then if you want to see it properly, then rewrite this fraction in product form. Then from there, compare them. Then this, it will be 0 to 2, what? It will now be 1, 4 plus x squared, exponent what? Minus 1 dx. If it satisfies the general power rule, then it's going to be lean because my no, it doesn't. Why? Because f is and what is the derivative of this? With 1. Are they are not like terms. They bring x here. They are not like terms. Therefore, the general power rule is out. The general power rule is out. Then which one is in? The general power rule is out. You can use the general power rule here. It's out. You can use it is. You can use it is. You can use it is. So which one is in? Then you have to go those to take goes to the techniques now and say if I don't say the whole denominator is f, but I say because of the square, then I say this is all squared. Then you will now be looking along this. It will now be this, which is there in your formula. I'm not sure which number is it, but that is not today's topic. So you have this. And what is this one here? It's inverse tan. Not sure which one. I'm not sure about the number. Which number is number 3 or number 4? I don't know. It's this number. That's right. And sometimes you may find it that this is not a monomial. It's a binomial. You can have something like what? Say 3 over what? Say 4 plus what? X minus 2 all squared dx. You see, something like this. Which it will be by, you have to complete the square. You have to complete the square. Sometimes you may not be given this because this is standard form now. It's exactly this. But sometimes you find that this is not in standard form. You have to complete the square so that it can match this. Then you know, oh, now my f is this. This is now my f. It's now my f. Now, do I have its derivative in the numerator, except for the constant factor? Yes, because you can take the 3 out, and here be left with 1. Therefore, the answer would be 3 multiplied by whatever answer. 3 is out. This is not a, it's a squared. Your function is x minus 2. Therefore, according to this, it will be 1 over a. If my memory serves me well, it will be 1 over a inverse tan of f over a. It will be this 1 over a inverse tan of f over a. Therefore, this now, you can see that, oh, this is exactly, it will be inverse tan. Because it's exactly this. The derivative over what? a squared plus f of x all squared is inverse tan. And if you have got a square root here, then it will be another formula. Don't forget that. If you have got a square root here, then it will be another formula. You see. So then, because there is no square root, therefore the answer here, as we have said, it will now be what? 1 over a. What is a? A is 2. Then it will be inverse tan of f. What is f? F is x over a. Then from there, that's right, it will be this. Then you evaluate it from 0 to 2. Then you can get the answer. It's straightforward now. But don't forget, inverse tan of this is x, this is x. X here is not degrees, it's radians. Therefore, when evaluating this, make sure that your calculator is in radians mode. Otherwise, it's going to give you a wrong answer. Hopefully that makes sense. You can just simply get the answer here. Yes, is there a hand?
So this formula is this one, I think is number 28. The formula you are using here for inverse formula. Mine here says
that is why I've said not sure about your numbers. Which number is number 28 or number what? No. I'm not sure about the number, but it's correct.
Okay. Is an in
okay. Yeah, just check it. Just check it. Is this one?
Yeah, I think
if
it's
that number,
if
that come again.
Yeah, it's almost similar, but okay, it says 1 over a arctan h. What
yes, remember, arctan and inverse tan is the same thing, written differently. Inverse sine of x and arc sine x, they are the same. Different notation. You can say inverse sine or arc sine.
Yes, but then the h, I thought it was a hyperbole something.
Come again?
There's an h here. It's arc tan h.
No, it's not hyperbolic. It must just be arc tan this x over a f over e. Otherwise, you are looking at the wrong formula.
Yeah, okay, which means you the a is in front of the f prime on this formula that you are using. The way your equation is written, the equation you're trying to solve on this inverse formula, it starts with f prime x all over 2 plus 2a squared, I think.
No, you are looking at the wrong formula.
Okay, I'll just look for the formula, then it's fine.
Yeah, no, you are looking at the wrong formula.
Okay.
Because remember, it must be this one. It must be this. Please check it. It must be this one. And this is this one. This is 1 over a inverse tan, or you can say arc tan. It doesn't matter. It must be this. This is this. I'm not sure about the one that you are looking at. The one that you are looking at is not this one.
Yeah, the one I was looking at, it starts with the f prime. The a is in front.
What do you mean by f prime?
This one, it's written a squared plus f at x all over 2. It starts with f at x over 2 plus a squared. Then it is equals to 1 over a tan arctan f at x over a.
And what I'm saying to you is what? You are wrong. You are looking
Okay.
at the wrong formula. I'm not sure which formula. It's just that I don't have that book to confirm whether it's number 28 or that is what I'm saying. I'm not sure about the number. Which number is it? But the answer is this one.
Okay. Yeah, I'm saying the one that seems to be similar to what you are doing there. It starts with f at x all over 2 plus a squared. Then it gives me that same 1 over a inverse of tan, and then f at x over a.
And what I like about what you are saying is similar.
Yeah.
It's not the same as this one. Therefore, don't say because this one is very close to this one and use it.
Okay. I'll just try to look for this because I was looking at the formula sheet, but I can't find the specific one that you are using.
You can't find this one.
No, I can find.
Sorry, just to
Yeah.
interject. My fellow student, it's rule number 25 there on the formula sheet. The formula that
Yeah.
says using is 25.
Sorry, yeah, I'm looking at 25, but then mine is start with f at x all over 2 plus a squared. That's what I'm saying.
No, but
Maybe
you
I
were saying
have.
number 28.
Just know that A is positive.
Sorry?
You were saying 28.
No, is that there are two. The 28 is an h, an hyperbolic function, and you said it was not the one. So is 25 and 28 the ones with tan. There's only two ones. There's only two with tans here, 25 and 28. My 25 starts with f at x all over 2 plus 2a. Then the answer is the same as the one you are giving here. And then the 28 has an h is tan h, hyperbolic function. And you said it's not a hyperbolic function. That's what I'm saying.
But
I can't find.
but on 28, the denominator is A squared minus F at X all squared. So that's the difference.
Yeah, I'm looking at everything. That's why I'm saying if you look at 25, it doesn't start with this a squared plus f at x all over 2. It doesn't start that.
No, maybe you don't. Maybe you are not using the same booklet. That is why I'm saying it doesn't matter which number is it.
It's fine as long as what you are written there is correct. I was just trying to find out if maybe there was.
Okay. Maybe they have updated it. We find that now they have reshuffled it. So this one says number 28. This one says no, it's number 7. And we find that you are both correct because you are using different booklets. But then the formula must be the same, irrespective of the number.
Yes.
That's right. Yeah, that's right. Now, let's go now straight now and use you can just finalize this and see what is the answer here. But now today, as we're saying, we are using the approximation formula. I'm just looking at the time here. So we are looking at the approximation formula. Now, say we are looking at the very same problem. They say use trapezoidal rule to approximate the answer here, which I'm not sure how much is it. Just check it for us so that we can just check it for us there. What is the final answer here? I'm just looking at the answer here. What will be the answer here? Because definitely you will need a calculator here. I'm just checking myself as well. 2 over, let's say 1. Oh, I've already created a fraction. Let me just proceed.
I think it's going to be pi over 8, sir.
The answer it will be 0, what? 39. Is pi over 8 approximately not 39? Let me just check. Yes, that's correct. The answer is this. Let us just squeeze it here, 0, 39. Now, using this now, the trapezoidal, you are now going to say, okay, how many, let's say we want to approximate it with what? Using 6 stripes. So the question is, approximate this. We know the answer. I can take it out. Say, take it out. Can take it out. And say, approximate this. Approximate the answer here. Approximate the area here. From x equal to 0 up to x equal to 2, where n is equal to 6. I don't have to rewrite everything. They say approximate the answer for this. Remember, they won't even write this. They will just say approximate the answer here, approximate the area between this curve and the x-axis from x equal to 0 to x equal to 2 with n equal to 6. Let us pause here. The question will be saying, approximate the area under this curve that is between this curve and the x-axis. From where x is equal to 0 up to where x is equal to 2, with how many equal, you are going to divide that section into how many equal parts? Into 6 equal parts. There from there, you must now approximate the answer using this. So now you start now answering it. You say, what is my n? Obviously, your n is equal, no, n is equal to 6. What is your b? Your b is equal to the upper limit, which will be 6, which will be 2, I'm sorry, which will be 2. And what about your a? Your a is the lower limit, which is 0. Let us take it slow. Then, what will be the length of each of those 6 equal parts? Can you get the answer for us? From 0 to 2, you partition it, that interval, into 6 equal parts. Then what will be the length of each? What will be the length of each? Which will now be this now. That will be the length of each. The length of each now, it will now be 2 minus 0 over 6, which is equal to 1 over 3. That will be the length of each. The first x is 0. Then how are you going to find the second x? Say you have something like this. Whatever. Say you have something like this. I'm not saying the graph, it will look like this. No, it will even go down. Not go up, but go down. Let us just indeed, because the y, it will keep on getting smaller and smaller. Say your graph will be something like this. That's right. If x here is 0, then we have partitioned this into 6 equal parts. Into 6 equal parts. 1, 2, 3, 4, 5, 6. That's right. Somewhere there. Into 6 equal parts. Good. Something like this. If x here is 0, and from here to here is 1 over 3, the lower limit is a is 0. And from here to here is the same as from here to here, is the same as from here to here, so on and so forth. If x here, the first x, meaning x0 is 0, then what will be x here? That is, what will be x1? It will just simply be x here plus this. And this is 1 over 3. Therefore, x here, it will be 1 over 3. In other words, x0 is 0 and x1 is how much? It will be from here to here, which is 1 over 3. And what about x2? That is x2 here. Obviously, it's a horizontal line, horizontal distance. Therefore, it will be x here, which is 1 over 3, plus this distance, which is also 1 over 3. Therefore, it will be 1 over 3 plus 1 over 3, which is how much?
2 over 3.
And here, what is x here? It will simply be x here plus this distance, which is x here plus 1 over 3, which is how much now? It will be 1, because it will be 2 over 3 plus 1 over 3. 2 over 3 plus 1 over 3, which is 3 over 3. Then, what is x4? Remember the last x, it must be 2. The first x is this. The last x is this one. So what is x4? x4, it will be x3 plus this distance. So it will be 1 plus 1 over 3, which is how much? 4 over 3.
4 over 3.
That's right. And what about x5? It will be x4 plus the length. So it will be over 3 plus 1 over 3, which is 5 over 3. And what about x6? It will be x5 plus distance. x5 is 5 over 3. x5 is 5 over 3. Therefore, what is x6? It will be 5 over 3 plus this distance, which is how much? Which is 2.
2.
Therefore, we are done. Not necessarily done, but somewhere halfway. We are getting somewhere. Meaning now, what is f of? Because here we were only looking at the abscissors, only at the x. But this is not using the x, it's using the f of x. This is just the x. But now this formula is using f of. Then you must now come back in here. Okay, then what is this? If x0 is 0, if x0 is 0, then what will be f of x0? Then it will be f of 0, which is how much? Then you write it here. You place x by 0. We know it. It will now be what? 1 over 4. Because you are going to, it's f of, this is our f of x. So what is f of x1? It will be f of what? What is x1? x1 is this. Therefore, it will be 1 over 3, which is how much now? You must now go to f and replace x by 1 over 3. Then you must now come here and replace x by 1 over 3. Just tell us the final answer. F of this, because it will be 1 over 4 plus 1 over 9. Let me just check. I'm not going to give you the answer. No. I'm just checking it just for myself. This, what I'm doing here is for office use only. It's not for you, ne? You still have to give me the answer. What is the answer? Hopefully you have your calculators. What is the answer? Anybody? Nobody's getting it. You don't have calculators. Our calculators are only these ones which are used in spaza shops, not a scientific calculator. I'm looking for my other marker, my blue marker. I can't find it. So what is the answer here? 9/. Anybody? No. You have an answer? Anybody? Because this is just pure calculations.
9/37.
Good. 9 over what? 37. Then what is f of x2? Because definitely this, it will now be what? It will be 1/4 plus 1/3 all squared. It will be this. You just use your calculator. Then the answer is 9/37. Remember, this it worth a lot of marks because it's a lot of work. So make sure that you understand it. Then you are able to calculate it. Otherwise, you are going to lose about 7 marks, 8 marks in the exam. You see, which is not nice. So this is f of what is x2? That is why we're taking it slow. What is x2? X2 is 2/3. Therefore, it will be 2/3. Then it will now be 1/4 plus 2/3 squared. And what is the answer? Is 1/4 plus. Remember, I'm not going to tell you the answer. What I'm doing here is for office use only. I'm just saying the answer. Anybody?
9/40.
9/4.
9/40. 9/40. Let us write it. I also got that. 9/40. So on and so forth. It will not be f of x3. You mustn't give up. F of what is x3? X3 is 1. No. This one you can leave it for me. No. This one leave it for me. Ne? That's right. This one leave it for me. This one is how much? 1 over what? Over 5. At least I also got something right today. Good. Good. Now, what about f of x4? This one is yours. I can't be doing everything for you, ne? That's right. This one is yours. This one is tricky. It's yours. Anything simple, you leave it for me. So what is the answer? Now I trust you. I'm just going to write whatever. I don't have to double check anything. We just write anything.
9
What
over
is the answer?
50.
Come again?
9/52.
9/52. If you have something different, and then you tell us. You tell us. If you have something different, you tell us. Now say f of x5. Remember, if you have something different, you tell us. It will be f of what? What is x5? Is 5/3. Yes. What will be the answer?
9/61.
9/61. If you have something different, please tell us. What is f of x6? It will be f of what is x6? X6 is 2. Then this one you can leave it for the teacher. This one is mine. Yes, leave the simple one for me. It will be this. And we are done. Then what next now? The next thing is now you come to the formula now. You have got everything. You now come to the formula. Let us just simply, we don't have to, yes, let us just simply write it there. It will not be the formula, it will not be half by what? What is b minus a over n? We are not substituting in the formula. It will be 2 minus 0 divided by 6. What is the answer? 1/3. It will be 1/3. In brackets, what then? In brackets, what? f of 0. What is f of 0? It's 4. No, it's not 4, it's 1 over 4. F of 0 is 1 over 4. Plus, don't forget the 2. Don't forget the 2. Don't forget the 2. 2 multiplied by what? F of x1. And what is f of x1? 9 over 37. Therefore, here it will be 9 over 37 plus what? This one. Don't forget it. It will now be 2 by what? F of x2. What is f of x2? 9 over 40. It will now be 9 over 40 plus what? This one, which is 2 by f of x3. What is f of x3? 1 over 5 plus 2 by what? This is f of x3. 2 by 9 over 52 plus f of this. 2 by 9 over 61. And what is the last one? The last one, there is no 2. It will just be 1 over 8. Then you calculate this. And then the answer, it must be very close to 0.39. You can just simply calculate this. The answer, it must be very close to this one. Because we are saying the approximation. But if you increase the number, maybe it's going to be 0.38. We don't know. Maybe it's going to be 0.37. But if you increase the number of partitions, you increase 6 to maybe 8. You increase 6 maybe to 10. Then your answer, it will get closer and closer to 0.39. But if you decrease your partition, you decrease 6 to 5, your answer is going to be now very far. It's going to get what? Farther and farther from 0.39. If you decrease your n to 4, then you are going to get something which is not even close to this one, which is you are now moving far and far and far away from the correct answer, which is 0.39, which you have said is something like pi over 8. And pi over 8 is the exact. This one is just approximation. Are you getting this one? Are you all of you getting this one? Or maybe you don't have scientific calculators.
It's there, sir.
Come again? Are you getting? If you are not, then there's something wrong. There's something wrong. It's either this or yourself that side, your calculator maybe doesn't have the battery. The answer, it must be very close to this one. It may not be exactly 0.39, but it must be very close to 0.39. Otherwise, there's something wrong. The best thing is what? Calculate this. The best thing is what? Find it, calculate this inside, calculate this one inside.
Yes, I'm getting it, sir.
And then thereafter, multiply it by 1 over 6.
Yes.
Calculate it. Say 1 over 4 plus, obviously, this is going to be 18 over 37. This is going to be 18 over 40. This is going to be 2 over 5. This is going to be 18 over 52. This is going to be 18 over 61 plus 1 over 8. If there is no space, then you say equal to, then say multiplied by 1 over 6. Then the answer, it must be very close to this. I'm not sure whether it will be exactly this, but it will be very close to this.
Yes, I got it, sir. It's exactly the same.
Anybody who gets something different? Tepiso, did you get something? All what it needs now is right. Just practice. Maybe you missed something in your when you were keying the digits here, the numbers here. That is why you are not getting this. It's no longer about you don't understand. It's no longer about the no. It has to do with what you need to be very attentive now. Make sure that you don't make any mistake when keying in the numbers. But fortunately, you can verify if that is integrable. You can just use those techniques to integrate it and get an answer. Then from there, see whether this answer is very close to this one. If not, then you know something's wrong. That is the nice thing about mathematics. Something's wrong. Let me just look for my blue marker here. Okay, yes, I found it. Good. Anybody who need help? Helen, are you still alive? Tavani, are you getting it?
Yes, I got it, sir.
Mahato?
Yeah, I just got it now. I just got it now.
Just now, after how many attempts?
Is it what 0.39? I think mine is
That's right.
0.39.
And all what it need now from here is just practice.
Yeah, okay, I got it.
Shongwe, did you get it right finally? Mahlatsi? Shongwe looks like he went somewhere now. Mahlatsi, did you get it right?
Yes, sir.
Tepiso?
Yes, sir, I got it.
Oh, finally, all good. Now, what we're saying is once you understand one, because they were saying there are three rules, three methods. Once you understand one, then the others, because they work the same. Let's do the very same thing and use Simpson's rule. Let's do the same thing and use Simpson's rule. And from here, it will just be about practice. And these rules, I guess, they are there in your formula sheet. So if they say use this rule, then you must use it. Simpson's rule says 1/3 in brackets b minus a over n. But don't forget, with Simpson's rule, your partition, your n, it must be an even number. It must be an even number. It says f of x0 plus what? Plus 4 f of x1 plus 2 f of x2 plus 4 f of x3 plus 2 f of x4, so on until the last one. That is the only difference between trapezoidal and Simpson's rule. It has got the first term is just f of x0, the second term is 4 followed by 2. Now from there they will just keep all alternating until the last one. Before this one, it must be 4 f of xn minus 1. That's all. The same story. You can just look at the very same question using this rule. It will now be what? Don't forget, this is it has got 1/3. What is n again? B is how much? We have said it's 2. What is A? A is 0. Therefore, what is the length of each? That is, what is this? It is still, no, A is how much? A is 0. But don't forget, A will not, it's not like A will always be 0. No, A can be any number. A can be 4. A can be 7. But obviously B must always be more than A. Because we are saying from A to B, meaning A can be a negative number. A can be what? It can be -1. It can be -1. Then from here, you must now come here and say B minus -1 over N. I'm just saying this so that we can do the same problem using these 3 different methods. So the same story. What will be your x0? X0 is always A. X0 is always A. Therefore, X0 here is still 0. And what is X1? X1 is always what? Because we have said we have partitioned that into 6 equal parts. Therefore, the length of each, we don't have to go back there. The length of each of those stripes, it will be 2 minus 0 divided by 6, which will be 1 over 3. Therefore, X1 is still 1 over 3. X2 is still 2 over 3. X3 is still 1. X4 is still 4 over 3. X5 is still 5 over 3. And X6, very important. X6, it must be the last one. It must be 2. X0, it must be the lower limit. X0, it must be the lower limit. And the last one, it must be the upper limit. If no, then you know something's wrong somewhere. That is a nice thing about mathematics. Then you go and correct it. Then from here, then you must now calculate what? Because these are the abscissors. You must still calculate what? F of x0, which will be f of, what is x0? We know x0 is 0. The same story. Then it will be this, which we know is 1 over 4. You just have to tell me the answers now here. From what is f of x1, which will be f of 1 over 3, we know the answer. We don't have to recalculate them with me. Unfortunately, I've erased them. I can't remember them. Because what we are doing right now is just for practice. What is f of x1? Zamat, we have said is f of this. You said is what? 9 over 37.
Yes, sir.
What about f of x2, which is this? Remember, we're still replacing x by this in f of x. F of x being 1 over 4 plus x squared. Said what is the answer?
9 over 40.
9 over 40. The same story with f of x3, which will be f of over 1 in it.
1 over 5.
1 over 5. Yes. What is f of x4? Hopefully you can see this. I don't have space. I'm trying to write.
9 over 52.
9 over 52. Then what is f of x5? Which is f of 5 over 3.
1 over 8, I think. Isn't
9 over 61.
9 over, is it 61?
Yes, sir.
Okay. This one, no, this one you can, you can leave it for me, this one. No, this one is very simple. Anything very simple, you leave it for the teacher, né? That's right. Anything difficult is for you. Good. Now, this now, let's come back and substitute now. Let us come back and substitute now in this formula. Oh, okay. Let me take this out and write this one, because we are no longer using trapezoidal, we are using Simpson. Let us write Simpson's rule here. It's 1 over 3 in brackets b minus a over n in brackets f of x0 plus 4f of x1 plus what now? Plus 2f of x2. How many terms are we going to have inside the brackets?
Sorry, sir. I don't know
Yes?
if it's just me, but I can't see there on top where you're writing.
Okay, okay.
Yeah, that's fine.
How many terms are we going to have? If n is 6. If n is 6. Then how many terms are we going to have inside the brackets? If n is 6. How many terms are we going to have inside the brackets?
6.
No. Remember, you are studying at x0. Then you are ending at
7.
x6. You are studying
7.
at x0. Then you are ending at x6. Therefore, how many terms are we going to have inside the brackets? If you start at x0, it will be what? 1 more. It will be 7.
7. Yeah.
That's right. If your partition is 7, then how many terms inside the brackets? It will be 7 plus 1. It will be 8 inside the brackets. Don't make that mistake. So it will not be up to 7. It will be 1, 2, 3. Let me write another one. It will be 4. What? 5. What? 6. And 7. It will be 7. Then from there, you can then now substitute now. It will now be 1 over 3. Don't forget, Simpson is b minus 1. It will now be 1 over 3. In brackets, what then? See, in brackets, what is f of this? What is f of x0? That is this one. This one is this. So 1 over 4 plus this 4. Don't forget the 4. 4 multiplied by f of x1. What is f of x1? This is f of x1. It will be 4 over 37. Don't forget, the next one is this 2. 2 by f of x2. What is f of x2? This is f of x2. 9 over 40. Plus what? Plus,
Say.
again?
The second term that you said, the first is 1 over 4 plus 4 multiplied by 4 over, not 9 over 37. I think it's 9 over 37.
Oh, okay, yeah, that's right. Oh, it's 9, isn't it? Thank you very much. It's 9. Where did they get it 4? Huh? Or maybe it's 4 here and then the 4 was in my mind, then I wrote another 4 here. Good. Thank you very much. And now this is 1, 2, 3. Then the next one is 4 by f of x3. What is x3? Is 1 over 5. Make no mistake. Now plus 2 by, that is 2. F of x4. F of x4 is 9 over 52. That's right. Plus 4 by f of x5. F of x5 is 9 over 61 plus this, which is 1 over 8. Then you calculate this. This we have said is 4 by 1 over 5. Then you calculate this. Then the answer here, it must be more or less it is. I'm not sure whether it will be 0.38 or 0.39 or 0.3 what, but it must be more or less it is. It mustn't be far. It mustn't be 2. It mustn't be 6. It must be around 0.39. Although it's an approximation. Otherwise, our method is not working. It must be very close to this correct answer, which we know, we saw it using that straight, the integral rule. Then from there, you just use your your calculator. We even have to wait for everybody to finish this. No, I don't think so. Just do it, then calculate it. You see, this is 4 by 9 is 36. This is 18 here. This is 4 over 5. This is 18 over 52. This is 36 over 61. Then this is 1 over 8. But don't forget what? To multiply it by 1 over 9 now. Because it's 1 over 3 by 1 over 3. You get this? Then after you multiply it by 1 over 9, then your answer must be very close to this one. Does it make sense? Anybody who got it?
Yes, sir, I got it.
So you see, then everybody will get it, né? Do you finally get it? B? The last time, don't forget, you didn't get it.
I got 0.40 something. Yeah, 0.40.
Yeah, then something's wrong.
Something's wrong.
Yeah, because somebody said he got exactly 0.39.
Okay, let me just double check.
Because if somebody got 0.39 and you got something different, then something somewhere, you cannot all of you be correct. Maybe you, yes, you are correct. And then the previous one, the earlier one is 0. I'm not saying totally you are 0. I'm just worried about these two different answers. Using the same method. Yes, if you are using different methods, yes, because it's approximation. But if we are all using the same method, then we must all of us get the same answer. You see, we must all of us get the same answer. But if we are using different methods, this one is using Simpson, this one is using trapezoidal, yes, that is a possibility. But if we are all using Simpson, then we must all get the same answer. Different answers, then it means we can all of us be correct. Anybody, Mahatu? Tavani? Helen?
I'm getting the different one, 0.5.
You got what? How much? Helen, you got how much? 0,
0.5.
0.5.
Yes.
Then 3 different students, 3 different answers. Somebody will say, yes, it makes sense because it's 3 different students, 3 different answers. But the truth is what? No, in mathematics, it can't happen that way. Somewhere you didn't punch the numbers correctly. Somewhere, which is what we're saying you must avoid in the exam. Make sure that you key before you move on, you double check. You key the numbers and before you move on. Come again?
The I had the very last term there, 1 over 8. I had it wrong. I think I wrote 2 over 8. My answer is the same as this guy's 0.9.
It's the same as. Okay. Now it's better. We can say it's good. because Helen still, I'm not even talking about the others, but we must, all of us, get it correct. But all what is left is what? Please go back and practice. Because if you understand this, then the only thing that can happen is what? As somebody has said here, you key in the wrong term. Once you key in the wrong term, you don't key 1/8, you key something else, then you are not going to get the correct answer. Therefore, marks, 1 mark or 2 marks, or even 7 marks gone. You see. Therefore, make sure that you are relaxed in the exam, and whatever you key in the correct before you press equal to. Go back, check whether indeed you have captured all the terms correctly. I'm just looking at the time here, and it says we must move on. What is left is just practice. What is left, it is just practice. Now the last one is what is called the mid-ordinate. The mid-ordinate rule. With the mid-ordinate rule, unlike the first two, you don't use the abscissors, the extreme abscissors. You don't use x0. You don't use x1. I mean, in the substitution. Remember, we have said this is x0. We have said A is 0 and B is 2. B is 2. And the length of that is 1/3. The length of each of those equal subintervals is 1/3. Hopefully that makes sense. That is this is how much we have said is this. That way we have said x0 is 0 and x1, whether Simpson or trapezoidal. This we have said is this. X2 we have said is 2/3. X3 we have said is 1. X4 we have said is 4/3. X5 we have said is 5/3. And X6 we have said is 2. Then from there we went to F. We were now finding f of x0, finding f of x1, finding f of x2, so on and so on. Finding f of x3, finding f of x4, finding f of x5, finding f of x6, and then going and replacing them, depending on whether it's Simpson, where it will be 4 by, depending whether it's trapezoidal, where it will be 2 by. Good. Now with the mid-ordinate, we don't use it. Remember, we've said something like this. We've said you have this. Then we have divided it into 6. Doesn't matter, 6 or whatever, it doesn't matter. Then we were using this. We were using x here, and thereafter, which we have said is x0. We were using x here, we have said is x1. We were using x here, which we have said is x2, so on and so forth. This time around, as the name is self-explanatory, mid. So we are now going to use the midpoint here. We are going to use the x here in the midpoint of your subintervals. We are not going to find f of x0. No. We're not going to find f of x1. We're going to use the x between x0 and x1. Does it make sense? You are now going to say, what is the midpoint of this one and this one? What is the midpoint here? Then you know how to find a midpoint. How do you find a midpoint? It will be the sum of the two divided by 2. So it will be 0 because it's 0 plus 1 over 3 because it's 1 over 3, then divide by 2. So which will be 1 over 6. So then it will now be, we are now going to use 1 over 6. Not f of this. It will now be f of 1 over 6. You get the answer. Hopefully that makes sense. And here, it will now be what? If you have this as 1 over 6, then what will be x here? It's very simple. Why? Because this is the midpoint. Because this is the midpoint of from here to here. Because this is the midpoint, then it means from here to here is equal to from here to here, which will be equal to from here to here, which will be equal to from here to here. Therefore, once you find this one, the midpoint here, if you are starting at 0, saying if you are starting at 0, so if the midpoint of the first one is 1 over 6, therefore, what do you do now going forward? You're just simply going to add what? You're just simply going to add 1 over 3. Let us just pause here and try to understand it. And try to understand it. Because here you are using the midpoint of this, which will be 0 plus 1 over 3 divided by 2, which is 1 over 6. And what about the midpoint of these two now? It will be 1 over 3 plus 2 over 3 divided by 2. What is the answer?
1 over 2.
It's 1 over 2. It's 1
Yes,
over
sir.
2. Then how can you get it is 1 over 2? You see, you just keep on adding them. 1 over 2. Is it 1 over 2? Yes, it will be 1 over 2. It will be 1 over 2. Therefore, now you are now going to say f of 1 over 2. Then you do the same thing until you have all the midpoints. That is no, until you have x of all the midpoints. Then from there, you go and substitute it into that formula. Then you get the answer. Then you can just simply use this method now and do the very same problem that we were doing. And you will see that it will give you more or less 0.39. It may not, as we have said, because it's approximation, it may not give you the same answer, but it must be very, very close to that answer. It must be very, very, very close to that answer, close to 0.39. And that is all. And that is all. But before we say, I saw one example there in your book. Look here. Let me just try to explain it. Here we give you F. Then we ask you to approximate the area. Hopefully that makes sense. We give you F. Then we ask you to approximate the area. What if now they want you to approximate the volume? What must they give you? Or what must you first derive if you want to approximate the volume using the very same method? You can approximate the volume using Simpson, approximate the volume using the trapezoidal, or approximate the volume using the mid-ordinate. So which function must they give you? Is it still F? No, it must be what? The area function. So you must first get the area, if that is not given explicitly, because in that problem, looks like they are just simply giving you the sides, the dimensions, to say the height is this and the width is this. Then use this to approximate the volume. Meaning you must now use the given data to find the area of each strip. To find the area of each strip. And then to find the area of each strip, then it will just be what? This side multiplied by this side, that is the area. The area of another one, this side multiplied by this side, that is the area. There from there, then use that function of area to approximate the volume. That's all. Hopefully that makes sense. That it makes sense. Finally, at last, Helen. Here you are given F. They want you to approximate the area. You see. So in that example, they want you to approximate the volume, not the area, the volume. Therefore, you must first get what? Use the areas now. How to find the area? I think they said the height is this, and the distance is this. Therefore, you must take the height, then you say it because it will give you the area. Then from there, use those area data now to approximate the volume. It will depend on whether you are using the Simpson. If you are using the Simpson, then it will be the area of the first, part plus what? 2, the area of the second part, so on and so forth. Any question before we call it a day? Because definitely we can't do everything. Eh? That's right. Any question, Robert? Do you have a question? If you're not sure, the next session you can still ask. Okay, say if you're not sure, you can still ask the next section. But right now, is everything okay, Mathazi? Can we call it a day? Yes. 3, 2, 1, go. Mahato. Going. 3, 2, 1, gone. B. 3, 2, 1, gone. Sepiso. 3, 2, 1, gone. Anybody that I didn't call his or her name? 3, 2, 1, gone. Thank you. Thank you. Thank you very much. And don't forget to stop recording. Eh? Otherwise, this video then is going to be very, very long. Please, those who have been given this responsibility of stop recording, please stop recording. And
yes, I'm doing.
And bye. And see you next week, Saturday, same time, God willing.